Thanks for staying with me today. So how's today? You have learned a lot on Keras by previous speakers, right? So next, continue to have some fun. My sharing today is more on AI image generation with Stable Diffusion using KerasCV. Just a quick question. Who has tried Stable Diffusion before? Or who know or who have ever tried it? Is it easy? What is your sharing about Stable Diffusion? In which platform that you have tried the Stable Diffusion? Is it hard? A lot of coding, right? Right. Yeah. So good news for you. If you try the KerasCV way, much simpler. You'll be amazed by it. And even for beginners who has never tried generate image using Stable Diffusion, let me show you how you can do it like an expert. After this session, then you can, I will share the notebook also, then you can run a bit on yourself, using different text that you want into. You can just showcase and like, whoa, I can do Stable Diffusion right now. Right, cool. Now, so stay with me today so that you can do it after this. So let's get started. I will be just sharing a bit more introduction background on KerasCV. Actually, in fact, I will start with Keras first, and then KerasCV maybe has been touched by other speakers. I'll just have a very brief go through on the KerasCV, and then the computer vision for those who has just want to explore the AI ML field, right? So you can get some backgrounds on that. So after that, let's go to the main topic of today, Stable Diffusion. You may know or heard about Stable Diffusion, or this could be the first time hearing this term. So we will go through like what is a Stable Diffusion, what is actually running backend, how it works backend, right? And after that, let's do I'll showcase to you how to develop Stable Diffusion image generation using KerasCV. Then you can follow along later. And let's have some fun time, generate some Stable Diffusion image, right? So before we start, let's have a very brief introduction on KerasCV and computer vision. Just a show of hand, who has tried to use or even still using Keras ML framework library? Some hands. Some maybe TensorFlow or PyTorch, right? So let's see what is Keras, right? So that's the reason why you're joining this today, Keras Community Day. So you will learn a lot more things. So a bit of history on Keras is actually developed by Frank Keras back in 2015. And if you have been in this Keras TensorFlow development for the past few years, right? You could still remember that it was first started together and then they separate. Now they are coming back. Yeah, so it's a very complicated relationship. But then still, I think in the current trend, there are reasoning behind it. Just to give you a bit more context on what is going on, right? Previously, it started with Keras. If you are in the ML AI developments, right? You know that there are a lot of ML libraries. TensorFlow, PyTorch, and then previously they even have from Microsoft, MNT or some others. So there are a lot of frameworks. That's why it's make developers very struggle, right? Like some projects are doing this framework, and then the other is using PyTorch, and then the next one is TensorFlow. It makes things crazy. So then in order to make developers, engineers' life easier, they want to combine standardize into a framework. That's how the Keras gets started. Then after that, but things changes, right? Then some of all these so-called popular libraries get fed up. It doesn't catch the attention anymore. So then become an issue, like the maintenance cost is much higher, right? But not many people are using all this library anymore. So then they want to separate out. And now things are more stable already. The main one, it will be like TensorFlow, PyTorch, and they are supporting JAX. If you have been heard before, JAX is a new library developed by Google, also in DeepMind, but it's more on research, doing a lot of acceleration and also to fight PyTorch. So this will be the three main ML libraries moving forward. So then they want to combine again, like to standardize everything you can interchange between different ML framework backend using Keras. So that's how this kind of split together, and hopefully it still stay together for a longer time. Yeah. So now Keras, right? Keras library initially is built on top of TensorFlow, and now it actually is beside Keras Core, which is the main core framework for Keras. You actually introduced two more. In fact, actually three. Latest one is still in kind of research development. It's not so publicly shared out. I will share later a bit on this. Let me go through this one first. The first one is Keras NLP. So Keras NLP, very straightforward. It's used for NLP. It's used for natural language processing. So if you are doing a lot of text ML project, then you can directly use Keras NLP. But I will not be focusing on Keras NLP today. What I will be focusing is simple. So we have Keras NLP, right? For computer vision, it's just KerasCV. You just import the library Keras. So what under the hood of KerasCV cover, right? You can actually directly generate the image classification, object detection, data augmentation, image generation, and all. So today I'll be more focusing on the more fancy things, the features, the image generation using the Stable Diffusion retraining model. So, but just to get you a bit more understanding on all this, right? So this will be the framework. So the third one, quiz. If anyone can already know, it's something tricky. Besides KerasCV, Keras NLP, what is the third one? Sorry? Yeah, but not really. I mean, it's more on for like CV, NLP is a domain, right? The Keras one is something also very advanced feature from Keras. You're right, but not my answer. Any trial? If not, then still is yours. Let's try. This is just a keep sharing. It's actually called Keras 3D. We are doing a lot of 2D, right? Upcoming will be Keras 3D, but it's still very early research. I see a few examples, but yeah, hopefully it will be developed more, and I think it will be most likely will be shared next year under some early preview stage. So looking forward for that. So a lot of text, but I will just going through in a short while. Then we look into more examples, right? So let's look for KerasCV for the young. So if you are new, if you are a beginner and things like that, one question that always asked is, which library framework that I should start with? TensorFlow, Keras, PyTorch, which one? But so this is a bit like promoting why Keras, right? So it's very easy. You use it for any. Sorry for others. So, and it support mixed precision training. What it means, this one is a bit for if you want to convert different, to run your model in different hardware spec. So some support 32 and then 16, and so you can actually convert it under Keras. So it's very easy. Then the other one is SLA compiling. This also a bit related to hardware. What you need to just understand for now is with SLA compiling, the model runs just faster, much faster with this SLA compiling enable. So this is why you should start your ML journey with KerasCV, right? But you may also need to evaluate what is on it. So, but what about for those who are already in the industry, who already know TensorFlow or try Keras or even some other libraries before? So is KerasCV still relevant? Yes, but then why? So something interesting for KerasCV for all these intermediate advanced engineer, right, is that it support a lot for CV lah, a lot imaging pretty models. Like we have YOLO. YOLO is object detection library, right? So it's the latest version for YOLO. Sorry? V3 is very, very long time no. V8, right? It's directly under support, it's already supporting. So you don't have to need to look for all these open source, then it's not really maintained anymore. Directly call or Keras, look the YOLO V8 model directly from KerasCV. So it's automatic start. So it sounds very nice, right? Very good start, right? So it has a lot of all these latest model available. So today we will try the Stable Diffusion. Right? Okay, exciting, promote. So let's look into some of the examples for KerasCV. So this is YOLO V8. V3 is quite some years back. So it's actually I think main contributor already kind of don't want to maintain it. So people just grab it and like improving, all right. So this is the YOLO V8 version. You can directly import the library, the model from KerasCV. So if you're doing some object detection projects, you can try this. Next one is segmentation. So also very powerful. You already can directly, you don't have to see where can I find the pre-trained model and what's not. It's already supported, direct supported. Image generation, this is what we are trying today. So image generation is in short, I give you the answer. I actually want to, it's a question that later. almost say, yeah. Maybe you already know what is image generation, what you need to, what is your input and what is your output, right? So, come to the question, Stable Diffusion, already got answered. So what is Stable Diffusion? Any trial? Image to text? Text to image, yeah, almost get me, almost. So it's actually very simple, text to image. You just write a text, a sentence, which auto-generate image for you. Very easy. You don't have to draw or you have to Photoshop. It's just in a click of time. So let's see how powerful it is later, and how easy you can just code it right away. So far so good, So now, I wouldn't go very deep into it because it will be a bit hard to understand, but just to give you a bit of concept, like what is actually running behind the scene, right? How does it work? So Stable Diffusion is not just by magic, right? So if you do some ML projects and things like that, even to understand a text or an image, it's already like the machine also is hard to teach it, right? So it doesn't, it's not magic. What is actually backend, right? A term that you may want to catch it today, latent diffusion model, is actually in creating this into the latent space. What is latent space, right? Is in short, is actually what the process is. If you still recall, right, there's this application called super resolution, right? Super resolution, what does it mean? A very blurry image here is actually fancy enough to do a super resolutionize it so that it looks very clear, very high resolution. So it's actually Stable Diffusion is actually getting the idea or develop on top of super resolution. the latent diffusion model started introduced and then captured by this super resolution. So this is a bit of the long sentence and all, but in short, it's just denoise the image, and then it's trying to regenerate the missing pixels. In that, of course, when it generate, right, you already improving it. Instead of the resolution low, you just increase the resolution. So then overall, the picture just much clearer in high resolution, looks like in high resolution. So the concept actually same for the image generation. So it's just denoising some dropping a few random pixels, and then it try to regenerate the pixels values with some other values. So then you can imagine that, like for this picture, right, I'll just take out all the pixels from the bottle. I change it to a flower or some other things, a vase, right? So then it's how it's getting the idea behind the stable diffusion is actually getting the idea behind the super resolution. This is all called the lantern space. And so it's denoising and then adding back the noise, but with a different noise, noise pixels. So this is the base of it, right? But makes the stable diffusion something extra. Answer is you need to have the input text, right? So then behind the architecture, you have actually a text encoder, a decoder. So then you have the denoising process, and then after that you just put back replacing the pixel or the noise with a different values and things like that. So in short, this will be what is running behind the scene. So like input, we just put a simple one, an astronaut riding a horse. Well, I don't know the horse can handle this or not, very heavy suit. So this is from the sentence, right? We will go through the text encoder. Then you will encode the text into all these embeddings. Then from there, you will send all these embeddings, text embeddings, to the diffusion models, and then you will try to learn what is the meanings of the text, right? Then you will try to generate and changing from, let's say I know it's astronaut. What is astronaut? It's just try to put in the pixels to generate an astronaut photo or face or something. Then you combining different text, then you generate an image. So I know that I need an astronaut and a horse, and the astronaut is riding on top of the horse. So then you just, the others pixels outside this scope is up to creativity already. So that's why you, with a simple sentence text, right, you can actually generate different images. So yeah, fun time, see how it works. I hope the collapse doesn't break. Collapse. See, you see, I trying to. Yeah, it's a bit unstable today. So I just show you what I able to run. So first, you just install this KerasCV library. Is it? This one I will also summarize it in the slide later. So through KerasCV library, then after that you just import the KerasCV library, and then you just call the model Stable Diffusion, and then you just put your image size. Simple, very simple. Yeah. You don't need to get a software engineer or ML engineer to do this actually. So then after you get the model, you load the model already, right? Stable diffusion model, right? You just call text to image. And then you just give your whatever image, a sentence that you want. And then you just put the batch size. So this batch size is how much epochs you want to run and like how it manipulates the images. So, and that's all. You can actually already generate the image and you can directly show it off. This is just to display the image. That's all. So how many lines of codes? Crazy, right? You want to try it, right? Try it later. So you can generate different images. You can try different texts. I don't know if I try. Keras mascot is unicorn, right? I tried unicorn. Wow. So fancy. Wow. You can directly do the artwork using this already. Can interesting. So behind there is some it's just an explanation and all. So this one I will explain this a bit more. So this is the denoising process, and then you will regenerate back the noise pixel values. Then you can form an image. So this is how it works in visualization way. So right, I think you want to try some text. I think I got a few more. Let's try this one. You want to do watermark. So how to do it becomes like how you want to generate the image, right? The key point here is how you put in the text. So you need to put it a very informative way so that you know like what you actually want to do. But if you just do a very short sentence, then the output may not be so nice. So you have to dump it a lot of things. If like you want the golden unicorn or what format, or you want the Van Gogh painting style or things like that, give it all these keywords, then you will try to do magics for you. Magic. So yeah, so it's very, very interesting. It's very, very fun, and it's very, very easy. Try this after this. So let's see. I think, yeah, if I have more time, then I'll come back to this. Let's go through the slide. Easy, recap back. How many lines of code? You install the KerasCV, and then you import the KerasCV library. You call the model, you load the model Stable Diffusion, and you put the image size. Then you just put the string that you want. Very easy, right? That's why I want to introduce you this KerasCV, especially for this Stable Diffusion. But of course, because it's so easy, right? There will be limitation. Of course, everything also got limitation. Room for improvement. So this is the basic, right? Then actually you can, if you are more familiar already, you want to try something more adventurous, more advanced things, right? You can actually change different hyperparameters, like the number of steps or the batch size and things like that. Then you can see like how the image being transformed generated. The pixel could be very from not so good and then become better and better, things like that. You just to understand how things works behind the scene and how you can manipulate your image generation better. Like then the other one is the unconditional guidance skill. I wouldn't be covering a lot of all this. So you can see by changing different more advanced parameters, right? You can get even different variety of output. So it's all about, not to say try and error experiment, but it's a smart way of experiment. You can directly see it, and it's not so difficult for you to maybe want to understand the mathematical algorithm and then like straight away. All right. Who wants to try this? Raise hand so that I can feel like so more advanced, right? The more fun things that is possible. I won't go through all this, but I'll share you the reference tutorial that I try out. Then you can just run it. But sometimes in under collab, right, the GPU sometimes not so stable that you will say out of memory, or sometimes it's disconnected and things like that. You need to take some patience, or if you have your own machine and things like that, you can already run it to understand better. So you can like putting it in a loop. What it does here, right? Putting into a loop, you changing some values of it, then you capture the image and then you compile it and become a GIF file. So GIF file is just image, image by image, right? So combining image by image sequence, then you can be a GIF file. So this is what is happening. So something looks fancy, fun, and things like that. So you can actually do this. You just change, updating the value in the loop only. And so far, so good. So why we want to use KerasCV for Stable Diffusion in short way? So it's part of the graph mode execution. Then it's SLA compilation through the Z compile. The default is already true. You can change it. We'll recommend you to stick to true unless you want to do some other more advanced things to see what is happening in your steps and things. So that it can run directly faster. Then it supports mixed precision compilation, like from 32-bit to 16 and so on and so forth. So very easy, and then you have some other extra advantage from using KerasCV. Yeah, so this is just a simple snapshot for the SLA acceleration time difference or the improvement on it. So you can see how much it improved. So like around half of it, right? Improve half of the time. But of course, what does the warm start means is already loaded the models and whatnot. You just it's just the model generation, image generation time. So this is warm start. But if you start from beginning, it's called cold start. Actually, the performance is not so good already. But why it's still a good thing? Because normally you just need to load your model once, right? And then you can generate multiple images along the way, right? Then this warm start actually gives more benefits. Okay, nice. Questions? Too easy, right? Easy until you cannot believe it. Question? No? And with the notebook also. I will share. I will compile or improve my slide according to the questions, and then I will share across to the organizer. Organizer will share to participants. No questions, too easy, right? Segmentation. I forgot the segment anything. Segment anything is not segmentation? Oh, no, I don't think then in that case, no, but it support segmentation, but using a different model. Because I think Facebook will be proprietary to Facebook. The model is not open source, so they cannot get it from Facebook model. You know what I mean? If you can also do that, that one will be more difficult in the sense that because all this make things very simple, is it directly load the model from the library, so it's already supported. So if you want to load any other models, right, you need to develop longer, like more, not to say from scratch, you need to build on top of like how to load the PyTorch, any PyTorch model from to Keras. Because Keras core backend supports PyTorch. You can still do that. But you need to load the model to Keras framework. Then from there you build the models, embeddings and things like that. Then you continue to do that. So it's not like simple, just 2-3 lines of code, because the model is not from here. You need to understand how the model architecture looks like and things like that. What are the things that you can do with the models, how to call their API and things like that. So you'll be a bit more low level coding. So this one is very easy, high level, because it's already supported. But you can try, I haven't tried this yet. You can directly try this. I would suggest you directly try this KerasCV segmentation model, then see if it already can produce what you want. If it can, then it's much convenient and make your life much easier. You can also, because like all these libraries or models, right? Example, right? You have multiple models actually achieve the same things, like the object detection. Besides the YOLO, if you don't like YOLO, you can have other models. So they actually can achieve the same things. So you just pick whichever is more convenient for you, but you can actually achieve the same result. So I would suggest you to try this KerasCV image segmentation model and see the output. Is it something that is good enough for you? Then you just switch it, then you can just change your model. If you want to stick to that model, it can, but it will be a bit more things to cover. I can share you some reference how to load the model from PyTorch, create from like PyTorch, and then you can see how you can get started. Yes. Sorry, upending for? I have seen that work before. I didn't cover this. What it does is I will improve my slide. I will put the reference. What the author has tried to experiment, right, is to get a picture of, I think, a man doing skateboarding. Then you change the man and to I think a dog or something. So it's from an image, and then you just change on top of the image. I think it's possible, but then you need to again go lower. This one is just direct. So that one you need to like get where is the location of the person and things like that, so that you can understand which region that you actually want to denoise, but remaining the other parts. I'll share. I'll add in. Good suggestion. Good question.
Is it a subject feedback mechanism? I could. Person I want to add has
something similar in painting. Yeah. So I think it is possible. I see some people share the work, but it goes a bit lower a layer. You need to do a few more steps. I see you're very interested in. Very good question. Yes. Yeah, like this one in painting is not so direct already. But it's possible, but I think the continue enhance on under this, it could be make also again easier lah. Some other models, some other libraries, maybe they already supported in their API, then it's very easy. But for this case, you need to go lower a bit to try to understand. Yeah, you need to control it also. So sometimes the lower, then there's this, I don't know here or not. You need to control some other parameters like the seed value and things like that. Then you can try different result output. So sometimes it may not be generating what you want. Sometimes it's just your text is not informative enough. Sometimes it's because of you need to manipulate a bit a lower layer of the hyperparameter. It's possible, but not so direct. Oh, so first try this, and then you can like experiment more, and then you can share to everyone. Then it will be very helpful to build the community. So hopefully, next time show to me. Think, oh, looks I can make this. I have you promote. And any other questions? No? Can I share? Try after this. That's all. Thank you.